Okay, question 11 is talking about stationary points. So it says this curve, I'm not going to attempt to draw that curve, has a stationary point. Find the value of the positive constant a, so a is positive, given that the value of the y-coordinate at the stationary point is 32. So we're going to need to differentiate first. And in order to differentiate, before we even start that, I'm going to need to rewrite my a over x as ax to the negative 1. Need to have that as a negative power so that we can differentiate it. So what are we going to get? We're going to get 8x. We are going to bring the power to the front and take 1 off the power. And the plus 5 goes to 0. So we've got dy by dx is equal to 8x minus a over x squared. At the stationary point, the gradient is 0. So if we set 8x minus a over x squared to equal 0, we should be able to work out what x is equal to. So I'm going to times by x squared. So that's going to give me 8x cubed minus a is equal to 0. So 8x cubed is equal to a, x cubed is equal to a over 8, and so x, the solution for the stationary point, the x coordinate, is going to be the cube root of a over the cube root of 8, which is 2. And we know that at the stationary point, the y coordinate is 32. So if we substitute x here into the original equation, we should get, we know, or we're going to set it to 32. So at this cube root of a over 2 point, we know that y is equal to 32. So I'm going to sub that in. So we've got 4x, I'll just write it out again, 4x squared plus plus a over x plus 5 is equal to y. So if we sub it in now, we're going to get 4 lots of the cube root of a over 2 all squared plus a over the cube root of a over 2 plus 5, and that is going to equal 32. So if we expand and tidy all this up, we've got 4 lots of the cube root of a squared. If I rewrite that as a fractional power, cube root of a is the same as a to the third. So a to the third squared is going to be a to the 2/3. So we've got 4 lots of a to the 2/3 over 2 squared. Second term, we've got a fraction over a fraction. So this 2 is going to bump up to the top. So we're going to have 2a over the cube root of a. And that's going to equal 27. I'm going to move this 5 to the other side. I don't know which side I'm going to want it, but I'm just going to move it out of the way for now. We've got 4 here and a 2 over 2 squared here. So they're going to cancel. So that's a to the 2/3. Plus 2 lots of, this time we've got an a over a to the third. And that's got a power of 1, so if we're dividing, we're going to take away the powers, so that's going to be a to the 2/3. So we've got a to the 2/3 plus 2 more a to the 2/3 is equal to 27. So that's 3a to the 2/3 equal to 27. I can divide both sides by 3. And then I need to undo this 2/3. So to undo it, we're going to apply the reciprocal of that power to the other side. In other words, we're going to cube both sides to get rid of the 3. And we're going to square root both sides to get rid of the 2. So it's going to be equal to the square root of 9 cubed, which is 3 cubed, which gives us an a value of 27. The reason it was the 3 rather than -3, I should have put plus or minus 3 in there, but we were told that a was positive, so that's why I chose the positive 3. To give us a positive a value.